Hello and welcome to the second half in this topic, in this data representation topic about how numbers are represented in three different numbering systems. In the previous half we looked at binary mainly, and today we're looking at, or in this video we're looking at hexadecimal. So let's skip all the binary things and go to hexadecimal. So hexadecimal is a base 16 numbering system, and that means that it has 16 digits to represent every number possible. So instead of 2 digits in binary and 10 in binary or decimal, it has 16. So we use 0 to 9 as our normal first 10 digits, and then we use the first 5 letters of the first 6 letters of the alphabet to do the rest. So A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. You've got to remember that it goes up to 15 because we have 16 digits in total and 0 counts as a digit. When I first learned this, I completely forgot about 0, and it confused me so much because I was using G instead of as the last one, because I thought it went up to 16. It does, but we use 0 as well. You've got to make sure you remember that. And sometimes we call it hex. We shorten hexadecimal to hex because it's easier to say and easier to write. And it's mainly used by computer programmers to represent binary numbers, because each hex digit represents a nibble. So for one hex digit, it equals 4 binary bits, and so less notations are needed to represent the same number. Essentially, it's computer programmers being a bit lazy, and it shortens huge numbers. So this huge binary number, which is equal to 12,500, is far shorter in hex, and this gets exponential. As this gets longer and longer, this gets slightly longer. So it really does help programmers. So essentially, it's used to shorten things. And so we've got to look at how we convert between binary to hex and hex to binary. Yes, so if we do an example of 31 into hexadecimal, 31 in binary into hexadecimal, so I can explain my thought process in this because I haven't actually written any help down. I make these PowerPoints quite a few, I think this was 2 weeks before I'm recording this now, so I don't totally remember this. So what you do, you first do your columns. So the way it works is, it's the columns is 16, and you are only going to be asked to do 2-digit, I can't say digit for some reason, 2-digit hexadecimal numbers. You don't need to do a third one. The specification does say that. And how it works is it's base 16, so you do 16 to the power 0, and anything to the power 0 equals 1. Any number to the power 0 equals 1, which is why all numbering systems start with using 1. And then you do 16 to the power 1, which is equal to 16. And the next one along, if you had a third column, which we're not going to do, it'd be 16 to the power 2, which is something like 156 or something. I'm not 100% sure. But you don't need to know. So what we do, my thought process is firstly the first column. So we've got to do 31 divided by 16, and clearly 16 only goes once into 31. If it went twice, that'd be 32. So it goes in once. And to find our remainder, we have to do 31 minus however many we've done, and that's 1 lots of 16, and that equals 15. And then simply, the way you represent 15 times 1 in hexadecimal, so the way you represent 15 times 1 is with, so this is 10, this is 11, this is 12, this is 13, this is 14, this is 15. So F is used to represent 15. Simply, this is 1 and F. And that is our hexadecimal 2-digit number, or number and letter combination, however you want to look at it. Okay, right, now we've got a harder version, and that is with a larger number, so 210 into hexadecimal. Okay, so we use our columns the same, 1 and 16, for the same reasoning above. And what we do is, firstly, like we did before, we've got to divide 210 by 16. And 210 divided by 16 is, let me just check on a calculator to make sure I'm being right. (210 divided by 16 is 13. And you are allowed to calculate it. Actually, you're not allowed to calculate it in your exam, but you can do that with long division or however you like to divide. So 210 divided by 16 is 13. Sorry, let's not we can't write that, no. Equals 13. We've got to be careful again. And 13, as we mentioned, in hexadecimal is represented by D. So instead of me writing 13 very stupidly, you write D. And then we have a we've got to work out for a remainder. So we do 210 minus 16 times 13, and that equals that equals 2 if you work that out, because 16 times 13 is 208, and 210 minus 208 is 2. And 2 in hexadecimal is simply the number 2. So 210 in hexadecimal is D2. Okay, let's move on. Let's have a look at converting hex to binary. Not binary, we're looking at that next. That's a spelling mistake, unfortunately. These things happen when you're rushing these sometimes. So 27 in hex, so this is 27 in hex. It looks like a normal number, but it's in hex, into binary. So first things first, we've got to write it in. So like binary, we write it in first, 2, 7, and we do our columns, so 1 and 16. And what this is saying is we've got 16 times 2 plus 1 times 7. You're timesing up or down, but you're timesing the column headings by the rows. And 16 times 2 is 32, and 1 times 7 is 7, which makes it 39. And that is your answer. This is far easier to do it this way, because you're literally timesing it instead of dividing. No one really likes dividing, but timesing isn't quite so bad. So we've got to look at 9c. This is a good point, by the way, that I might not have mentioned. You can have hexadecimal numbers clearly from your 15 units, they don't include letters. That's a good point. You don't get confused because they don't have letters in. Don't assume that because it's like this, it means binary. It should be quite clear in your question. Okay, so we do 16 times 9 plus 1 times c, and c represents 12. Oops, there we are. Going off my screen there. 16 times 12. 16 times 9 is 160 minus 16, which is 144. Plus 12, which equals 166. Nice and easy, I think. That's possibly 3 or 4 marks that are really not that hard to gain. Okay, now we've got to look at converting straight between binary and hexadecimal equivalents of the same number. And they're interlinked. It's really clever how this works. I really like it. It's good when you finally understand it. So a nibble can represent the binary numbers 1 to 15. For example, 15 is 1111. 4 ones, if I said 5. 4 ones match on nibble. Nibble is 4 bits. And as we know, these are our headings for binary. And we're literally just adding them up. 8 times 1 plus 4 times 1. 8 plus 4 plus 2 plus 1 equals 15. So that's nice and simple. We covered this in the last video. And these 4 bits, this nibble, can also be represented by 1 hex digit, as it has 15 positive digits. It has 1 to 15. So for working for the nibble, 1011 in hex is this. So we've got our binary number here, and we're working out what this binary number means in binary first. So 8421, 8 plus 2 plus 1, because 4 times 0 is 0, is 11. And we take this 11 and we straight away convert it. So we know that 11 in hex is B. 10 is A, B is 11, C is 30, 12, etc. So we know that 11 in hex is B, and that's our answer. 1011 in hex is B because of this. Really clever. Let's have a look at a slightly harder example that also represents it slightly better. So we've got a byte here. We've got 8 bits, 00111011. So convert it into hex. Dodgy animations there. But we have our binary numbers here. We have our column headings. And, important, you have to look at the nibbles individually. You can't then do 16, 32, 64, 128. You've got to act as if they're 2 different unities, which is one of the reasons why they have a gap in between them, because you look at them individually. But if you look at binary, you look at them together. If you look at hex, you look at them individually. So we've got to look at them individually like we did here. We add up what they mean. So 8 plus 2 is 10, and 2 plus 1 is 3. So what this means is, as we know, 3 in hex is simply 3, and 10 in hex is A. And so, ta-da, our byte in hex is 3A. So hopefully that makes sense. I'm going to pause this slide and look over it again. If not, there are plenty of videos on the internet about this, but this is tailor-made to your course if you're following the OCR GCSE course. So anyway, thanks a lot for watching. Next up, we're looking at the character section in this topic, in this chapter I should say. So hopefully I'll see you in that video. Thank you.